Hello, everyone. Welcome to our wonderful live stream that we have, an AMA that we have with Avail and KYVE. Today, we're going to be talking about trustless data for scalable blockchains. And today, we have with us a wonderful set of panelists here, and we'll be exploring how Avail and KYVE are collaborating to make Avail's blockchain data permanently accessible with KYVE and open up new opportunities to visualize and analyze what's happening on chain. So let me quickly introduce our panelists here today. Today we've got Jackson from the Avail team, who leads Validate Engagement. We've got Fabian, who is the founder of KYVE, and we've got Christopher as well from KYVE as well. So yeah, I mean, hello everyone. How are you guys doing?
Hey man, doing well.
Hey, thanks for having us.
Yeah,
Awesome.
likewise.
Yeah, so let's kick things off with a quick introduction. Like introduce yourself for a bit, and then what you do at where you work at. Like what do you do at Avail or at KYVE? And I think that would help things kick off for this discussion. Yeah, Jackson, do you want to start?
Sure man, yeah. Hey guys, my name's Jackson. I'm Validator Engagement Lead at Avail. My day-to-day operations are basically making sure everything's running smoothly on chain, keeping all our validators happy, managing technical upgrades, governance processes, making sure all the wheels are well greased. Generally speaking, at Avail, if you're not familiar with Avail, we provide scalable, verifiable data availability, primarily for rollups and app chains, with our Avail DA, and then build on that by enabling trust minimize interoperability with Avail Nexus, soon coming to mainnet.
Awesome. Then I'll take over. I'm Fabian. I'm the founder of KYVE. We do permanent blockchain data archiving. So that means basically we take blockchain data like from the A layers, but also like from other like more traditional blockchains. Basically, we archive them. We make them available for developers. We build tools around basically all I would say like different data products we're building. Like Christopher is one of the devs that is making that possible. I'm also a software developer myself. Started KYVE 5 years ago now, so quite a while ago, and still super excited basically about what we're all building.
Yeah, maybe I can take it from there. So I'm Christopher, software dev at KYVE, as Fabian introduced already. I was mainly working on the Avail integration. Also, I'm working on the tools to leverage the data that has been validated and archived by KYVE. Also a huge fan of DA, was very hyped working on the Avail integration, huge fan actually on myself. So very happy to contribute to this new ecosystem.
Okay, great. So Jackson, let's begin with you, right? Let's first of all talk about how we got to this collaboration, right? So, like I mentioned before, like we're working with KYVE here for our permanent data storage solution.
Mm-hmm.
But tell us more about what that means for Avail. Like, what's the difference between Avail's DA, like data availability, which is commonly known to be a temporary data solution, versus this permanent data storage solution, and how, as like some people might be confused about these two ideas, right? Like, how do we differentiate between these two, and like how does Avail work with KYVE in that matter?
Sure. Yeah, it's a great question. And like you mentioned, without it being explained, I think a lot of people would say, but data availability is the same, right? They're both producing the same service or product. And I think that's where, like, maybe if I could break it down into a couple sentences, you'd have like, with Avail DA, is the block data available right now as it's being finalized so everyone can verify and build on it? And then a permanent storage solution like KYVE, can I come back days, months, years later and still find this exact data? So we kind of see that, Avail as a DA layer makes sure that all the data for a block is published, retrievable, provable by anyone at the network. And basically, like you mentioned, doesn't keep that data forever, right? It's not really needed to be an archive solution as such. It basically guarantees that at the moment of consensus, all the transaction and rollup data is available so it can be validated. And then even if there are archive nodes in the mainnet network, its core processes aren't really forever storage. Whereas the permanent data storage solution, its purpose is to keep that data, I mean, in talking marks forever, but let's just say for a long time, so it can be retrieved at any point in the future. So, a permanent storage solution doesn't really care about when the data is published, just more so that it's stored for a long time, remains accessible. And I guess, yeah, again, the confusion or the maybe lack of understanding can just become between, DA on a data availability level is more short-term consensus critical, and the permanent storage is more long-term and archival. But in my view, and I think all of us here probably agree, using them together is like a double-edged sword. It's a great partnership. Basically a roll-up composes block data to Avail for the DA guarantees, and then also have that same data pushed to permanent storage solution for historical record keeping and future querying from either their own teams or teams that are building in their own environments as well.
Right. Yeah, that's actually quite interesting. Because rollups, even though they have the need for data availability for a temporary purpose, they will still probably require that archival data later on for indexing purposes, which is one of the use cases that I think we can have this permanent data solution for. But Jackson, let's also maybe dive a little bit deeper into how Avail's infrastructure kind of works. How does it ensure like scalable and reliable data availability? Could you just give a quick breakdown on how all of that works?
Sure. I mean, you have a few different layers there, right? The scalability, reliability, and security. In a decentralized network as we have, so we currently have 105 active set validators, through a pretty strong spread of stake or decentralization of stake, as is common in substrate based chains. You see this across Polkadot as well. You have, generally speaking, higher Nakamoto coefficients, and so the security of the chain, the wider it grows, the security of the chain grows with it. The decentralization of that stake within the active validator set means that there's a much higher threshold for fault tolerance or bad actors to have to, you have to collate. I think our Nakamoto coefficient at the moment is like 33 or 34, meaning that you'd have to control that portion of the network in order to halt consensus, which is not impossible, but it's very improbable. So we basically already have quite a proven, robust decentralization in the network. On the protocol level, we operate with Babe and Grandpa. Babe's role is in block production. So we basically ensure that new blocks contain all the necessary data commitments, and that those data commitments are published in time. And then Grandpa manages finality within the protocol, and basically prevents phantom blocks or blocks without accessible data from ever being part of a canonical chain. So we through that protocol, validators are basically not going to finalize a block unless the data commitments that are inside it are valid and available. So once that block is finalized, we can basically cryptographically guarantee that that data was available and correct at finalization. And at Avail, we have basically the protocol built with erasure coding. And so without erasure coding, you can have without erasure coding, you basically have the ability for a malicious block producer to hide a small piece of data or corrupt that state, meaning that it'd be super difficult to reconstruct that state later. But with erasure coding, basically you split the information up enough that in order to validate it, you only need a chunk, and an entire block can be kind of recreated or restructured from a small piece of information. So validators can store portions of state information, and then it can be reconstructed at a later stage, which is a really core part of basically being safe from withholding data attacks. Yeah, so basically that's how we build up the protocol. Babe and grandpa keep us safe.
Yeah. Babe and grandpa keeps it safe, which is a funny thing to say in this in this space, but yeah, I mean, like, so Fabian and Chris, like, how do you guys like think of, so like Jackson just explained the data availability part of it, and so in now when we talk about KYVE, how does KYVE's validated network guarantee data integrity and permanence without these central intermediaries? Like, how does KYVE's validated network ensure that the data isn't, keeps its integrity?
Yeah, happy to like say a couple words about this. It's almost similar from the like basic idea. So basically, we have also like a decentralized network. Of course, we have I think around 50 nodes that are active, like in the Avail data pool. And what they do is they run their own Avail node, and basically, like they sync their own data with the network. So they basically always assure, that they are up to date and they're not, all using the same RPC point where like wrong data might come up, basically. And then what happens is one of those 50 validators is randomly selected based on their stake. And then basically all the other 49 validators need to vote if they have the same data or not. So if they have the same data and everything is fine, it's cool. We basically publish this, piece of information. And if it's like more than 50% say, no, I have different data, then that person receives a slash, so gets punished for providing wrong data. And then another validator gets chosen and we remain on the same block height. By this, we ensure there is no gaps ever in the data, and we actually create a full-on historical archive. And we had cases with other networks where, like sometimes we were stale for a couple of weeks because, like nodes were trying to figure out what the right piece of information is, basically. So it's a decentralized, like distributed POS. By the way, basically, yeah, we make sure everything is archived and validated, and then we use Arweave as our permanent storage layer. So all of our pieces of information is getting stored on Arweave. Arweave ensures up to 200 years of data storage and considers this permanent. And basically, yeah, so every single piece we store is there for 200 years and then can be retrieved from developers on the other side. And maybe Chris can quickly expand also into like our Trustless API and like how we make sure that actually data you retrieve is also fully functional, basically.
Thanks, Fabian. So happy to move on there. So yeah, exactly as you mentioned. So of course, the interesting part of KYVE is the whole validation part. So everything that happens before the data gets uploaded onto Arweave. But then, of course, we want to offer like products and tools to leverage this data and to make use of the data as efficient and as easy as possible. Which is why we then end up implementing the Trust API, which is basically just an API endpoint. The idea behind it is that it mocks the original API endpoint. So everyone who will use the Trust API endpoint for the Avail data will hopefully be familiar with the how the endpoint looks like, how the schema looks like, and because we try to be as seamless as possible to the original, to the origin API endpoint. And when a client wants to retrieve the data, it then just queries the API endpoint, and it just not only returns a data item or a block, or for example a data submission on Avail. It also comes with a proof, and the proof is basically a Merkle root, which then can be verified via just a simple Merkle verification, Merkle proof verification, and can be like verified by querying the KYVE node. So basically, you just need like one external API call after you retrieve the data, and there the client itself can choose which node the client wants to query from. So basically, the client can choose a node that is like trusted for him, or can also choose his own node, or just use a random node to then make sure the data that has been retrieved by the client is verified by KYVE. So we tried to get rid of the dependency of just a random API endpoint. We wanted to make use of the proof and of the validation we did before storing it on our permanent storage solution, which we ended up then adding the proof to the Trust API, which is why it is called trustless. So you don't rely on any like centralized source or centralized RPC endpoint provider, you just can verify it by your own and just need to trust the decentralized system at all. So yeah, that's the idea behind the Trust API.
Wow, okay. That's quite, there's a lot of moving parts happening there, which is really cool. So I guess this was more about how KYVE's network kind of works. Is there anything to add on when it comes to the permanent storage solution, or is it pretty much the same? Or do you want to maybe expand upon that a little bit more?
I can also quickly touch base on like how the incentivization around all of the archiving works, because I think we found like a pretty neat solution around it. So if you're a validator on KYVE, which means you're uploading storage, you pay for the data that you use in KYVE tokens. So basically, this is like you need KYVE tokens from somewhere, and you get them like A, from network inflation, but also B, multi-coin reward tokens from all the partners we work with. Which means basically, that if you're a validator on KYVE and you archive, 20 different blockchains, you also get like those 20 different tokens basically as a reward, for providing like this validation services. Also means that for you as a staker, you also get the multi-coin rewards there basically. So it's a quite interesting incentive mechanism where you're not only dependent on KYVE, but you're also always kind of like dependent on like the other network provider. And I think this gives kind of like a unique incentivization mechanism there on how it works, especially, with all the staking and slashing then coming into play when you actually provide wrong data. So like we have, high stake, high risk, and therefore like good rewards as well.
Wow. Okay. Interesting. That's quite nice. So moving on to kind of going deeper into the integration part of things, right? Jackson, I think one question that some of the I guess users or like people watching this might have is like, why would an app like use Avail DA, because it is a temporary posting service, instead of just posting it to a permanent storage provider, right? Like this can be including KYVE or like RV or Filecoin or IPFS or whatever it is, right? Like, why would an app choose a DA layer like Avail DA for data posting instead of just posting it to some permanent data storage provider?
Sure. I will attempt my best to explain this, and the smarter minds that are on here can correct me or add to it, because I know Christopher and Fabian are big brained in this regard. I think there's a couple of things. I think one is definitely cost efficiency. For an app to like basically archive everything, all their data at once would be quite an expensive operation, especially with these high throughput rollups. It'd be a pretty massive cost, especially on places like KYVE, etc. I think with Paul and some of the other team, like when we were initially discussing setting this up, I think we ran through like with another partner that was inquiring about it, like how much should it cost to like store this much archive data on KYVE, and it was like a ridiculous amount of money. So I think the cost benefit definitely comes into it. I think on the consensus side, basically that rollup needs the DA for consensus, right? Even if one transaction or piece of block is missing, they can't prove state transitions. So a DA layer like Avail allows for basically no data to be hidden, proofs to be generated, and then those cryptographic proofs to be there inside the block production and finality. So basically, the consensus critical environment gives that rollup the proof that it needs to go back out into the wider industry and say, this is what we've done, and we can prove that it's been validated basically and finalized. I think there's probably some latency and finality as well. Latency, I'm not really sure exactly how much quicker it will be. I think it would probably be a little quicker. Obviously on finality again, basically where DA networks are optimized for like fast blocks. I know that obviously we're building out, we're currently sitting at 20-second block times, and we're looking at, bringing that down much more, in a few X's down to like, what we're looking at, I think 8 or 6 seconds in the coming time. And so, needing to finalize state quickly, Avail DA provides that. Other DA layers provide that that finality in a quick process as well. So there's definitely efficiency on time. And yeah, again, like the permanent storage solution is definitely optimized, not so much for speed, but more so for that archival historical data. I don't know, guys, if you want to add anything, if there's anything I missed, or yeah.
No, actually, you described everything perfectly. Maybe I can just explain why we have this this time gap, or why we optimized on like permanent storage solution, and especially validation rather than speed, because of course, like it takes time to find a decentralized consensus of the data, as a process that Fabian explained earlier. So we just need to make sure that the data that has been proposed is actually valid. So we need to provide time for all of the validator as participants to query their own node and to verify if the data is valid or not. And of course, this takes some seconds. Right now, like I think we have an average of like 1 minute 30 seconds. So yeah, this takes some time, which is why we optimize on validation and permanent solution rather than block speed, which is why I also think that we have a good fit here.
And maybe also like adding one other thing that we focus on with permanent storage too is, for most of integrations, we carry basically the whole state around from like Genesis block 0, right? So like we have actually some integrations where we need to have a sort of called like catch up time, like some networks that might have launched like 2 or 3 years ago. We still need to start at block 0 and really, like catch up, make sure there are no gaps basically, and then coming like slowly but steady into like a live height basically. And so this is, why like for us that we really care about it. It's actually, Jackson, what you said, super interesting with like data you store versus block time. So I think Arweave like really like, the permanent storage solution, I think has like 6 to 10 minutes block time, sometimes like up to finalization, like I think we sit somewhere in between, like DA is, like a little bit faster. And I think like you can always optimize, either for like data throughput, or like data availability in the sense. And so you guys are already, like finding like a very sweet spot, and especially if you bring it down, to like, I think you said like 6 to 8 seconds, you're like in a fantastic spot basically to, like provide like this more temporary storage. And it's something we couldn't even optimize for in that sense. And so like, it's very nice, how you have like DA and permanent solutions that go hand in hand basically on that layer.
Yeah, it's quite interesting. It's like almost like in the like it's almost like comparing like a RAM versus a storage kind of situation there. Like if you want quick fast access to data, you want to quickly post some data, quickly retrieve it. You can use like a DA layer kind of thing. It is temporary, that's fine. If you want a more longer term storage solution, you go to like the main hard drive, right? Like that's something like how you you would equate it to the traditional world, I guess, which is quite interesting. I think also DA layers kind of add on the ordering guarantees as well, right? Like especially like Avail, because we are a blockchain by itself, which is optimized for data availability. That means not only do we give like the data availability guarantees, we also ensure that that the ordering of that data that is posted is also maintained throughout. Whereas in many data storage providers, ordering may or may not be guaranteed there, right? Like you can post the data, you know that the content is there, but you don't know, like you can't guarantee the order in which it was probably posted. And that is something that a DLA sometimes provides in greater guarantees. So moving on, let's maybe just talk about how the end-to-end flow from Avail block production to KYVE validation happens. Fabian, maybe you can take this, like how are the validators, you also mentioned something about the incentivization as the validator. So let's go from like the Avail block production to the KYVE validation, how these validators are going to be incentivized in that economic cycle.
Yeah, absolutely. I mean, Christopher, do you want to, I go over the incentivization part, and then Chris can go over basically the, like technical part as he led the integration on this. From an incentivization perspective, it works like this. You run a validator on KYVE, and you choose to run it in a certain data pool. In this case, would be Avail, basically. You sign up, you check our docs, you start, like all the necessary requirements, you sync your Avail node, you connect, potentially to like an RPC node and stuff like this, and you attract stakers and delegators. And by this moment on, you participate in validating Avail data. When it's your turn, you upload the data that you have. The others check, is it the correct data? If yes, you get an amount paid out. It's a mix of KYVE and Avail tokens. And basically, if not, then you get slashed. So you're always incentivized, to do a good job, upload as much data as you can, so you get the highest amount of rewards, basically, that you can keep, you can share with your stakers to attract more standard, like proof of stake model, basically. And if you feel comfortable with like one data pool, you extend to more and more and more. And we have some of our like top validators actually running in all the different data pools that we have, and providing, I would say, like a very vast, like value addition, like cross ecosystem, cross technology. It's super, super interesting. And maybe now Chris can talk a little bit about how it works specifically for Avail.
Yep, maybe maybe I can start on the Avail part, because like the only requirement on the Avail side is of course setting up the node. So you would need to set up your node, to run the node, to start the node, to sync some blocks. And this is basically the only requirement for the Avail side to then successfully join the pool. So for example, if you are already an Avail node runner and have a running node set up, or you are also like node runner in different networks, then this is actually the biggest requirement, the biggest work that needs to be done in order to join the KYVE pool to get rewarded for your work. So if you are like a Avail node runner, you could also check out our docs to see if it might be feasible or might make sense for you to join the KYVE pool, to just like add just some rewards on top of your already running node and already set up node, which is then super easy, because the actual KYVE node, which we call the protocol node, that is responsible for querying the node and then either propose the data to get validated, or to validate proposed data. So basically to upload data or to check if the uploaded data was valid or not. This is the only thing that the KYVE protocol node is doing. So it's a pretty lightweight process. And it's just been added on the potentially on the same machine as the Avail node. It doesn't take much hardware, so you could actually check that out if you want to join the Avail pool. And if this node is set up, and then if the KYVE protocol node is set up, you can then just join the KYVE pool. And as Fabian explained, then the whole decentralized validation process starts, and you can see the KYVE protocol in action, which is fun to see. Okay, how does my node perform? Did I upload? How did I vote? How is the upload process going on? And the thing is, we are trying to be as boring as possible for the uploading process, because of course our goal is that a node proposes the data, and the data is valid, everyone agrees, and then the data just gets uploaded onto Arweave, which is successfully the case for Avail, because you guys did a great job. And we don't see much like a non-deterministic data, which is of course bad, because this is then the requirement for like a whole decentralized portion of nodes to find consensus of the data. And because like if one node has like, for example, which would be super critical, which would have like a block hash for block height 10, which starts with A, and another node has a block hash that starts with B for the same block height, then of course we can't find consensus, and the data that has been proposed is certified as not valid. So we need to move on to find like the majority of nodes to agree on a certain block hash. And so this is then it's super interesting to see, okay, how does the data look? Okay, is the data deterministic? Is it valid for everyone? But of course, we try to aim to be as boring as possible, to make the upload process as boring as possible. And hopefully you won't see any like invalid slashes for the Avail pool going on.
Like now that you brought up slashes, my next question was about to be something related to that, right? Like you mentioned, like if there is some non-deterministic thing that happens, or like something that turns out to be a malicious behavior according to the KYVE network, how does the slashing and the consensus ensure that data is trustworthy, or like how does it manage that? How does slashing happen there?
Yeah.
And then what basically?
So we operate by like a 50% threshold. So if more than 50% of the stake says this data is invalid, we mark it as invalid on our chain. The node that proposed it and uploaded the data gets slashed. There are different types of slash. So one is if you're the uploader but don't upload data, that costs you tokens. If you upload invalid data, it's the worst. We change those parameters basically throughout the time, so you can check them out on AppKive Network. You can see kind of like where we stand there. And so, yeah, and there's also a slash if you don't vote, basically, so there are like different types of like penalties for being inactive. And then what we do is, instead of then just going on and say, hey, okay, we didn't find any validator for block 10, let's move on to block 11 and see what happens there. We actually repeat block 10, until we find like a valid consensus. And we had this happening for chains like Osmosis, for example, where there were like bugs early on where like the data just didn't match up. And sometimes for weeks, while pool was stale and some validators were figuring out like, where is the error coming from? And then basically, like agreed on like what, type of data to use to be able to, move it forward. So like sometimes there is like a manual, intervenence that needs to happen to unclog the pool, so to say. But for most pools, especially when we're there from the beginning, we don't have these problems, at all. So this is just kind of like how it works. Sometimes, proposes unintentionally wrong data because the underlying code is buggy. Had happened before. We have an insurance, you get paid out again. Okay, but sometimes, we had nodes where there was misconfigurations or actually just like straight up wrong data. And then of course, a slash is absolutely valid and needs to happen. And then it also happens like fully automatically. So this is how that works.
Gotcha. All right. So let's see. I think I've got a couple of other questions before we wrap up. So this is to the general table here. Like, why do you guys think it is important for Avail to leverage a permanent storage provider in your view? Maybe we can go around the table on that.
Yeah. So I think that basically permanent storage is very, very important because right now it's like an overlooked problem in the space, in the industry as a whole. I think we think of, like a blockchain to be always there forever, but it actually isn't at all, because if you think about it, you only get money and you only get incentivized for providing new blocks. No one is ever getting paid for keeping old blocks around. And there's zero monetary incentive to do so. So if I'm a node runner and I want to optimize my business, what I do is I delete the old data. And so, like no one is saving it. And it's actually a problem that isn't that bad yet on like the bigger chains, like on Ethereum, we see it now with like the EIP 4844, 44444 discussions going on, with like, what do we do with the old state? Do we just delete it? Do we move it somewhere else? And then especially, how do we prove it? Because if we can't prove it, then what was the whole point of building all that data decentralized in the first place? And so I think it's like, getting more and more relevant basically in like those discussions. We also do have some like chains we work with, which I won't disclose publicly right now, but where they do have a data gap, where they were like, oh yeah, like 2 years ago, we didn't really worry about archival nodes. And like, no one has the data anymore. And so it's like, how do we get it back? So like they actually have to work with partners like us, basically, where we slowly but steady reconstruct the data from the beginning. And so I think this is like, for me, where data permanency comes in, because we just take it as granted by just building a blockchain, meaning the data is there, but it's actually not true at all. Like blockchain only means new data is being produced decentralized, but the rest is like not guaranteed at all. So for me, this is where the important factor comes in.
I can totally agree on Fabian's perspective. And I think, like, as he mentioned, as he outlined correctly, I think, especially in the EVM ecosystem, we can already see the shift towards like getting rid of the old data we don't need anymore. But I think the idea behind Avail, behind like any major DA chain, basically, is to provide the best infrastructure as possible for other projects to build, for example, on Avail, to then leverage their like consensus mechanism, basically leveraging their security to then build whatever. So build like any kind of application, any kind of roll up. And I think like it's important for us, or for infrastructure providers like us, like Avail, but also like KYVE, mainly focusing on the data part of it, to provide the best tools and the best possible like suite basically to make the ecosystem attractive for rollups to then for example like on Avail you don't need to think about that the data has been made available or not, because Avail is doing a good job there. And if a rollup relies on Avail, they don't need to think about that, and they just can focus on building a cool product, building like cool things on top of Avail. And on KYVE, we're just like adding one pillar to that, focusing on the data infrastructure. So the rollups building on Avail, they don't need to care about, okay, do we need to store the data, or what happens with the data, and what happens with the data submissions we posted on Avail. And because Avail has made them available, of course, the data has been made available for short or even midterm, but it isn't like ensured that this data will be like retrievable forever. So we as KYVE, we just like add a pillar to that already like great ecosystem, to that great tooling within Avail, and we just make sure that like the projects building on Avail, the rollups building on Avail, the people that want to join the ecosystem, like they don't care about, like they don't need to care about like the shitty stuff. They don't need to care about data infrastructure, which is like most of the time it isn't that funny, to be honest. To build like a cool tool to store data permanent, but of course it's a super important topic. And I think adding like a permanent storage solution to a DA layer like Avail is just like adding a pillar to a already nice ecosystem to make tasks even not required anymore for rollups building on Avail basically.
Yeah, and just to add to that, agreed totally with what both of you guys said. And I think from a quite common pain point is that protocols managing archival solutions themselves is heavy and expensive, primarily because it's not incentivized, right? If a foundation's running X amount of archive nodes, or if external partners are running archive nodes, it's usually not incentivized in any form. Maybe you can have some kind of secondary incentivization through a larger foundation delegation or nomination, something like that. But usually the protocol itself doesn't incentivize an archive node operation. So what I love about KYVE is that you kind of copy the environment and run this environment in which the archival solution is there, but it's also incentivized for the people that are running it, which I think is quite a novel and like really cool new space to move into, because what's normally heavy, expensive, taxing on whoever's running that archive solution, it's less, or it's not heavy, taxing and challenging, because you're actually being rewarded for doing it. And so instead of a protocol needing to change the way they operate to like incentivize through the protocol or through token dilution that you then incentivize that archive solution, you can bring in someone like KYVE and have KYVE incentivize it for you, which I think is a big thing, because a lot of these larger chains with high throughput archive nodes are massive to run and expensive. So not only for the foundation to be able to utilize KYVE, and for the internal engineering and development teams to be able to utilize that archival solution, but also for operators that would like to offer that service, they have an incentivized operation, which is, at the end of the day, that's the bottom line, right? And so, I'm really excited that you guys are bringing this forward, and also just want to say, like, it's kind of really cool to see it finally coming together. I know that it's been a little while for us to integrate together, and I was just reflecting today, Chris, on when you and Paul basically like hard pitched me at breakfast in Brussels one morning. I think I was like grabbing a plate of eggs and toast, and Paul's like, "Hey man, can we like sit at the table and chat about KYVE and Avail?" I was like, yeah, sure, let's do it. And then I think like literally the next morning I come down for breakfast, I grab a coffee, and Paul's like, "Man, Chris was working overnight. He's like already integrated Turing. Like we're up and running. Like let's go on mainnet." And it was just really cool. You guys were super energetic, and when Paul explained to me what it was, I was like I just had all these like little explosions going off in my head. Like, this is amazing. Like, why didn't we do this before? Why doesn't other chains do this? Like, so thanks guys for what you're bringing. It's really cool, and excited to see this go to mainnet. I know a lot of operators that would love to be involved if they're not already involved. So fantastic work, and excited to see us working together.
Well, I really appreciate all those kind words. Thank you so much. We're also very much looking forward to that.
Yeah, that's a very interesting story. I did not know about that.
Well, they were staying at the same hotel, right? Where we were in Brussels, they were at the same hotel.
Yeah, it
So
was crazy.
it's
It
almost
was
every
actually crazy.
morning, and I don't know if they like planned it, but yeah, we got the cold pitch at breakfast. It was good. It was really good.
Yeah, I think we wish our like CRM would be the level where we would know where our like prospects would stay, you know, so we can have breakfast with them. No, it was completely like unplanned, but very cool. And almost, yeah, as you said, like a year ago. Time flies fast.
Yeah. Literally, I think maybe this month was a year ago. Yeah,
Yeah, I think
Yeah.
so.
Yeah,
really
it's
cool.
crazy how hard sometimes this 80-20 rule kicks in. So this is like a great example for it.
Yeah.
Yeah, that's actually quite cool. Okay, so we are almost done. I've got a couple more questions. Quick, rapid questions. I guess you could answer. First one would be, what's one killer use case I guess you could expect from this integration, like, or like, what's one thing that you hope to see that comes out of this integration?
Yeah, I think it's using Avail data at scale. From a KYVE perspective, we have like three main like data tooling around it, mainly targeted, you know, for like data analysts or like heavy data builders, and utilizing them. Like they all work out of the box. They're really cool. You can load your data into like your big data warehouse and do all kind of cool stuff. And the other thing is the Trustless API that Christopher mentioned already, kind of like really decentralizing your data stack. That's like the thing I'm excited the most about.
Jackson, anything from your end?
Yep, I would echo that, and I'd also say that I think like the visualization of data is going to be really cool, and so it's something that I think we haven't really been able to tap into so well yet. But having large chains like Lens and so on integrated into Avail, I think there's going to be some really cool like ecosystem-wide visualization of how data's coming into Avail and how much is being produced and stored, etc. So I think from my side, that's what I'm excited to see, like a little bit more representation of what's happening behind the scenes. And obviously through KYVE's solution, that makes it all that much easier.
Yeah, totally can agree to that. I would also love to, after wrapping everything up, going towards mainnet, I would love to then like dive into the freshly created data set to then get like beautiful insights, get some stuff out of it that actually looks informative and nice, and happy to play with it actually.
Awesome. So last question. Let's go. What are the next big milestones from your teams in the next 6 to 12 months? Jackson, if you want to go first.
For sure. I think for us, the main milestone is Nexus. Obviously, we've kind of been talking about this a lot lately. Nexus going live with mainnet's going to be huge, and I think the pending interoperability that's going to come through our current ecosystem when Nexus go lives, and then how the ecosystem will expand from there will be probably the largest thing I think we've done even since TGA of DA, honestly. It's like that next step in Avail's evolution, and I see that being massively effective in allowing all of our partners to have that smooth cross chain experience, whether it's moving assets without custodial bridges, or just having that composability across what would be isolated rollups. I'm really excited for that. So obviously that's coming very soon. I think also some updates in DA coming down the line. We'll start to talk about those soon, as not everything is fully finalized, but basically we're going bigger and faster. And so I'm really excited for that to come down the line too in the next couple of months.
That sounds very exciting. From the KYVE side of things, I think the last year's really focused a lot on our product and not that much on like the KYVE token itself. And so we have done like a big push to improve the interoperability around, like KYVE, like availability of the token basically. So we have just released like our hyperlink module. So now we're gonna create some more bridges to other chains. It's like I think one thing we're really pushing forward to, as well as we have a new chain upgrade coming live next couple of weeks on testnet, which introduces liquid staking and other things. So for us, like this year is kind of like time to focus on this, as well as like closing new partnerships on like the data front, as we have done there. If you're an active listener, of KYVE, like you can always check out. We do a couple of like proposals for public good funding mechanism, which is where we run a validator on the other person's chain, and we use those rewards to fund the data on KYVE. Really strengthening like the public good relations. We have a couple of proposals that went out there. So for us, it's like a lot of ecosystem and token work, basically what we're heads down on. And if you haven't seen it, we also have a new staking dashboard that just went live a couple of weeks ago, which replaces the older legacy web app a little bit. So that's like things we're excited about.
Yeah, maybe one last thing from my side, like thinking about the integration and what my goal is, especially for the integration, especially also around the tooling of it and building a cool product, would be definitely to have at least one, maybe some more roll-ups actually telling us, hey, you guys did a great job. We're using us, we are using our tools. Mainly also like requesting like maybe more features to then just expand the tooling in the ecosystem and to keep building a nice product and to make the Avail experience just better for any roll-up from a data perspective.
Okay, so yeah, that's all from me for today. Thank you all for joining. It was a great conversation about our collaboration, about how KYVE has helped us with the permanent data storage solution along with Avail DA. We've discussed how all of that ties in together, how DA is separate from permanent data solutions, and all of that good stuff. So I mean, I'm super excited to see where this goes and see what kind of things that we unlock with this collaboration. So yeah, I mean, thank you guys for joining. It was a wonderful conversation to have with you. Thank you and have a great day. Bye-bye.
Thank you so much.
Thanks, guys. All the
Thank
best.
you, guys.